So we've looked at the sum and difference formulas for trigonometry and the double angle formulas. In this video, we're going to look at the half angle formulas. Our objective: use the half angle formulas to evaluate and simplify trigonometric expressions. Okay, what do we know that's going to be relevant here? We know the double angle formulas for cosine. As you'll recall, there were three versions. I've noted two of the three versions here. We're going to use this second version to derive one of the half angle formulas, and then the other version here will be used to derive the other one, which I won't do. I'll just derive the one and you'll see how that works. We also know, of course, that given a right triangle, the sine of an acute angle is equal to the opposite side's length divided by the hypotenuse's length. Cosine is adjacent over hypotenuse and tangent is opposite over adjacent. And finally, we know our unit circle trig values. I actually decided this time instead, I printed out a unit cycle, or I came up with a unit cycle chart. A little easier than writing it all down, but these are the trig values for 30, 45, 60 degrees, and then using those same as you add 90, add 180, etc. 30 degrees, of course, being the same as pi over 6, 45 degrees being the same as pi over 4, and 60 degrees being the same as pi over 3. So we'll make use of our known trig values from our unit circle chart. Okay, so let's use one of these cosine double angle formulas to derive the half angle formula for sine. Again, we can do the same thing with the other double angle formula to derive the half angle formula for cosine, but there's no need. You'll see how it all works, and if you want to go forth and do that, you can. So let's take the double angle formula for the cosine. Let's take this one, 1 minus 2 sine of alpha squared. I'm not sure what that period is there, but there shouldn't be a little period there. Okay, so I'm gonna write, as opposed to using alpha, I'm gonna use theta, and you'll see why in just a minute. It's the same formula. The cosine of twice an angle is equal to 1 minus 2 times the sine of an angle squared. Same formula. Now, I'm going to say, let's let theta equal alpha over 2. Okay, so whatever theta's degree, we're going to let that be alpha divided by 2. And let's replace theta here with alpha over 2. So we have, this is the cosine of 2 times alpha over 2 is equal to 1 minus the sine, 2 times the sine of alpha over 2 squared. Okay, so now we're here. And now we are going to solve this equation for the sine of alpha over 2. Solve for the sine of alpha over 2, because this will give us the half angle formula for sine right here. Well, first, of course, we know that the 2 times alpha over 2 is simply alpha. So the left side is now cosine of alpha equals 1 minus 2 times the sine of alpha over 2 squared. Okay, now I'm going to move this to the right, adding 2 sine of alpha over 2 squared to both sides, and I'm going to shift this one to the left. I'm trying to get to sine of alpha over 2, so I want to get it by itself. So I have 2 times the sine of alpha over 2 squared is equal to 1 minus the cosine of alpha. Again, I move this term to the left, and I subtracted this term from both sides, which moved it to the right. I can now divide both sides by 2. Okay, so I have, excuse me, the sine of alpha over 2 squared is equal to 1 minus the cosine of alpha divided by 2, dividing both sides by 2. And now I take the square root of both sides. Whoops, I just lost you. I'm looking up at my phone. Let's make sure we've got you on the screen here. So now I'm here. Now I can square root both sides. And I have the sine of alpha over 2 equals positive or negative. When you take the square root, you get a positive and a negative. 1 minus the cosine of alpha over 2. And you're done. We just found the half angle formula for the sine function. It's equal to positive or negative the square root of 1 minus the cosine of alpha divided by 2. And as I'm sure you can see here, if we do the same thing, if we let cosine of 2 alpha equal, if we go up here and we use this formula instead, and we solve for cosine of alpha, the same process takes place and we will come up with the half angle formula for cosine. No reason to do that one as well. It's the exact same process. Okay, so here we have the half angle formulas for sine and cosine. Let me get my papers turned over. The sine of alpha divided by 2, so the sine of half the angle of alpha, is equal to plus or minus the square root of 1 minus the cosine of alpha divided by 2. We just derived that one. And the other one which we could derive, same process, the cosine of alpha divided by 2 is equal to positive or negative the square root of 1 plus the cosine of alpha divided by 2. So notice what is the difference between these two? The sine of alpha over 2 has a minus here. The cosine of the half angle alpha over 2 has a plus here. Now, which sign do you use? Well, that depends on the quadrant in which the angle alpha over 2 lies. Okay, where is that? Where is that angle alpha over 2? Obviously, if it is in quadrant 3 or 4, the sine is going to be negative because the sine is negative in quadrants 3 and 4. If it's in quadrant 2 or 3, the cosine will be negative because the cosine is negative in quadrants 2 or 3, otherwise positive. Okay, so let's take a look here. We're going to make use of those formulas. So I'll leave them somewhat displayed. Use the half angle formula to evaluate the sine of 11 pi over 12. Okay, well 11 pi, this is your pi over 2. So this is the sine of pi over, we want to find the sine of this half angle. And we know that 11 pi over 12 is in quadrant 2. Okay, 11 pi over 12 is a little less than pi. So we're in quadrant 2. We're thinking radians here with pi. And since we're in quadrant 2, we know the sine in quadrant 2, the sine is positive. Okay, so we want to note that. Okay, so when we use our half angle formula, we're going to choose the positive because our angle, our half angle here, the sine of 11 pi over 2, is in quadrant number 2. Okay? So now we need to know what alpha is. If 11 pi over 12 is alpha over 2, what's alpha? Okay, so if alpha over 2 is equal to 11 pi over 12, well, then alpha equals 11 pi over 12 times 2. We need to double it. And that's 22 pi over 12, which is 11 pi over 6. So we need to know both alpha over 2, which we were given, and we need to know alpha, which we just simply did. We simply doubled our alpha over 2 to get alpha. Alpha is 11 pi over 6, and that is one of our trig, our unit circle our unit circle trig values that we can find the exact value of. So, the sine of 11 pi over 12, we know it's positive, so we can choose the positive. We need to choose one of these two depending upon which quadrant the alpha over 2 lies. So it's positive, square root, here it is, 1 minus the cosine of alpha. We determined that alpha was 11 pi over 6. All that divided by 2. Okay, well that's equal to, I don't need to keep carrying the positive. We know when we don't see the symbol that it's positive. So this is equal to 1 minus, well, what is the cosine of 11 pi over 6? Let us get our unit circle out. Okay, and we're looking, here's 11 pi over 6 here. We go around, we get to 11 pi over 6 here. The cosine, of course, is the x value. It is root 3 over 2. That's the exact value. So this is root 3 over 2 divided by 2. And that's kind of a mess. That's the answer. That's kind of a mess. So we can continue here. We know this is the square root. I'm going to write this. I'm going to see if I can't do something about this denominator here. Let's see. 1 is 2 over 2. So this is 2 minus root 3 over 2. All of that divided by 2. Okay, and that's going to give me, right, I just wrote 1 is 2 over 2, and okay. So dividing by 2 is the same as multiplying by a half. So this is the square root of 2 minus root 3 over 4. Okay, and I'll go to the right here because I'm out of space. Whoops, I've lost a bit of space on the bottom. Well, that means the numerator is going to stay a square root because that's just a square root. There's nothing you can really do with that. But the square root of 4 is 2, and there is your answer right there. The sine of 11 pi over 12 is equal to the square root of 2 minus the square root of 3. All of that divided by 2. Not pretty, but you know what? Not all numbers are pretty. Let's check that. Let's see what our calculator says. Okay, so we notice we're in radians. We've got pi here. So we want to be in radian mode, and I'm currently in degree mode. So I will go into my mode, and I'll get into radians. Okay, so the question was evaluate sine of 11 pi over 12. Well, let's do that, see what the answer is. The sine of 11 pi divided by 12 in, again, we're in radians. Looks like we've got 0.258819, etc. And now let's check this answer here. We just found this is the exact answer. Let's see if that's true. This should be the same thing. I'll get out my fraction bar. I've got division going on here. So that's going to be a mess. Square root of 2 minus, there's a square root under a square root. That's okay. Our calculator can handle that. And there you have it. Same thing. So this approximate value is 0.25, looks like 88, if we round to the 10,000ths place there. Okay, so that's an example there for you. Evaluating using the half angle formula. Let's take a look at this one. We want to simplify this expression. The positive square root of 1 plus the cosine of 96 degrees divided by 2, giving the result in terms of 1/2 the given angle. Well, positive here tells us up here that we're using the cosine of pi over 2 because that formula has the positive under the radical there. Okay, let's see. So we know, again, that plus tells us we're doing the cosine of alpha over 2. And we know that in that formula, this 96 degrees is our alpha. Okay, so let's see here. the cosine, we know our formula, the cosine of alpha over 2 is equal to the square root of 1 plus the cosine of alpha over 2. Okay, we already determined it was positive. So let's see here. I'm going to go ahead and write this piece first. So this piece, 1 plus the cosine of 96 degrees divided by 2 is equal to the cosine of alpha over 2. Well, half of 96 is 48. This is equal to the cosine of 48 degrees. And there you go. The result of this is the cosine of 48 degrees. We're done. Okay, the result in terms of 1/2 is cosine of 48 degrees. We are finished. Now let's check that. Okay, we have a calculator. Now we're in degrees. So let me, I think I've got enough space here to show everything. I think so. Okay, so I'll go back into my calculator. I'll go back into my mode and choose degrees because now we're dealing with degrees. Let's first check this. So it's a square root. I've got a fraction underneath it, so I've got a fraction in there. 1 plus the cosine of 96. All of that divided by 2, and that comes out to be 0.6691. And let's compare that. It should be the same thing as the cosine of 48 degrees. Cosine of 48 degrees, 0.6691, etc. So this is approximately equal to 0.6691, rounding to the 10,000th place. Okay, one more example. As I drop papers on the floor, almost. Okay, let's take a look at this one. Find the value of the cosine, let me get my other papers ready, the cosine of alpha over 2 if the sine of alpha is equal to -4/5 and alpha is between 180 degrees and 270 degrees. Okay, so alpha, first off, obviously we're in degrees here. Alpha is in the 3rd quadrant. Well, wait a second. We need to come up with where, if we're going to come up with the right formula, we need to find out where alpha over 2 is located. So I'm going to take this and I'm going to divide all these pieces by 2 because I need to know where alpha over 2 is located in order to come up with the correct sign for the cosine. 180 divided by 2 is 90, and 270 divided by 2 is 135 degrees. Well, alpha over 2 is located in quadrant 2. That's between the quadrant 2 is 90 to 180. And the cosine in quadrant 2 is negative. Okay? All right. So now let's take a look at what this tells us. We got to come up with some cosine information here. Now I know that alpha, the angle it's given here is in the 3rd quadrant. It's somewhere over here. I'll draw that out. And I know that, so here is my 3rd quadrant. Here is my right angle. So here's my right triangle. I know that the hypotenuse is 5. I know that sine is opposite over hypotenuse. So the opposite is the -4 right here. Because the opposite in this case is in the y direction. And of course in the x direction, we are -3 because we're in quadrant 3 for alpha. Okay, so now we can come up with what our cosine of alpha is because we need our cosine of alpha for our formula. So let's use it. The cosine of alpha over 2 is equal to, well, we know it's negative. We know that alpha over 2 is negative, so we have a negative formula. Okay, go back to our half angle formula. In this case, we know it's negative, and it's 1 plus the cosine of alpha. So it's 1 plus the cosine of alpha divided by 2. So that's why we put alpha in here so we could find the cosine. Okay, so it's the opposite of the square root. And this is 1 plus, well, the cosine of alpha is adjacent over hypotenuse. So this is negative 3/5. We'll divide this by 2. And that's your answer. It's a little bit messy, but let's clean it up. This is the opposite of the square root. 1 plus negative 3/5 is 1 minus 3/5, which is 2/5. Divided by 2. When we divide by 2, we multiply by 1/2. So this is equal to the opposite of the square root of 2/10, which equals the opposite of the square root of 1/5, because 2/10 simplifies to 1/5. And there's your answer. Okay, that's the answer to that one. If the sine of alpha is negative 4/5, with alpha in quadrant number 3, the cosine of alpha over 2 is equal to the square root of negative 1/5, with alpha over 2, of course, in quadrant number 2. So there you have it, the half angle formulas for sine and cosine. You know, take your time, draw pictures, use your formula to make sure you're in the right place and doing things, show the work, because there are, as usual, there are plenty of opportunities for small, silly mistakes that we don't want to make.